All right, so you know that feeling, right, when you're staring at a coding problem and it's like it's written in a foreign language you've never even seen before?
Totally.
Yeah, you just don't even know where to start.
It can be super overwhelming.
Exactly. Wouldn't it be amazing to have like a system or a roadmap to go from that blank stare to like, Eureka, I got it?
Oh, yeah, for
Well,
sure.
you are in luck because today we are diving deep into a blog post from Algo Academy, and it's called How to Create a Plan of Attack for Any Coding Problem.
Sounds promising.
Yeah, and trust me, this is going to be a game changer, whether you're a seasoned coder or just starting out.
I love that they call it a plan of attack, like we're going into battle.
Yeah, it does kind of feel that way sometimes.
Totally. But what I think is so cool about this approach is that it goes beyond just like the steps, like a recipe. It helps you understand not just the HIW to solve problems, but also the WHY behind those strategies.
All right, because that's key for actually mastering the art of coding.
Totally. It's like knowing the moves in a martial art, but also understanding the philosophy behind them.
I like that analogy. Okay, so let's imagine you're tasked with building like a simple calculator app.
Okay, basic, but a good place to start.
Right. It seems easy enough on the surface, but even something this simple can benefit from a structured approach.
I'm sure you're right.
So Algo Academy starts off strong with their first step, and it's all about understanding the problem. And it sounds obvious, right? But they really emphasize dissecting the prompt before you even think about writing any code.
Okay. I can see how that would be helpful.
Yeah, so, what are the inputs? What's the desired output? Are there any tricky edge cases hiding in there?
Oh man, those edge cases can get you.
Yeah, for sure. But thinking about them up front can save you a lot of headaches later on.
Definitely. And, I've seen so many people, especially when they're under pressure, just jump straight into coding without really taking the time to fully understand the problem.
Yeah, that never ends well.
Never. It's like, I remember this one time I was working on a project with a team, and one of the developers was so eager to impress that he just dove headfirst into writing code without like fully grasping the requirements. And he ended up spending hours optimizing a complex sorting algorithm only to realize later that he had completely missed like a key detail in the problem description. And it wasn't even necessary.
Oh,
It was
no.
a classic facepalm moment.
Okay, so lesson one, don't be like that guy. Take your time and really make sure you're solving the right problem before you even start writing any code.
Couldn't agree more. Double check those requirements. It'll save you so much time and energy in the long run.
Absolutely. And that leads us perfectly into step two, which is all about analyzing the problem.
Oh,
So we're not just reading the problem here. We're like putting on our detective hats, looking for clues.
okay. I like that.
Right. So we're looking for patterns, potential roadblocks, any hints that can help us craft an elegant solution.
So it's about really dissecting the problem and figuring out what we're dealing with.
Exactly. So with our calculator app example, we'd start thinking about things like, how do we handle different operators?
Yeah.
Plus, minus, multiply, divide. And then what about decimals? What about error messages for invalid inputs?
Yeah, all important considerations.
Right. It's all about breaking down that big, scary problem into smaller, more manageable pieces.
That makes so much sense. It's like instead of trying to eat an entire cake in one bite, you cut it into slices.
Perfect analogy.
Right.
And, something that's helped me immensely over the years is pattern recognition.
Oh, tell me more about that.
Like I was once working on a project that involved image processing, and the task was to identify specific shapes within an image.
Okay, sounds challenging.
It was. But by really analyzing the problem, I realized that the shapes we were looking for had these unique edge patterns. So I developed an algorithm specifically tailored to detect those patterns. And it simplified the solution so much, and it actually improved the accuracy.
Yeah, that's awesome. It's like you cracked the code.
It felt that way. Those
Mm.
aha moments are the best.
Yeah.
And, it's not just about blindly following steps. It's about understanding the logic behind them.
Totally agree. And that brings us to the super crucial step 3, planning your attack. So now we're choosing our weapons.
I like that, getting our arsenal ready.
Exactly. We're talking about choosing our algorithms and our data structures. These are the building blocks of our solution.
So back to our calculator example. This is where we decide how we're going to store those numbers and which algorithms to use for each operation.
Like addition, subtraction, multiplication, and all that good stuff.
Yep, and this is where choosing the right algorithm is super important. It's like choosing the right tool for the job.
Uh-huh.
Like you wouldn't use a hammer to screw in a screw, right?
You'd end up with a mess for sure. And this is also where that concept of time and space complexity comes into play. How efficient is our code?
Right, and that's a big deal.
Yeah.
We want to find the most elegant and efficient way to solve the problem, not just any solution that works.
Right. Efficiency is key, especially as your programs get more complex and handle more data.
Totally.
Yeah.
So can you break down time and space complexity a little further for those of us who might not be super familiar with those concepts?
Absolutely. So imagine you're cooking, right? You could make a simple omelet, or you could cook like a five-course meal.
Okay, I see where you're going with this.
Right. So the omelet is quick and easy. It doesn't require many ingredients or fancy cookware. But that five-course meal, oh man, that's going to take a lot more time, a lot more ingredients, and a wider range of tools. And that's essentially what time and space complexity is all about. How much time and memory does your code need to execute?
Oh, I love that analogy. So simple, but it really makes sense.
Right. We want our code to be like that omelet as efficient as possible.
Awesome. Okay, so we've dissected the problem, we've analyzed it, we've planned out our attack.
Yeah.
Now comes the fun part. Step 4, implementation. We finally get to write some code.
Time to put all that planning into action.
But hold on. Algo Academy isn't just talking about any code that works. They emphasize clean, readable, and maintainable code. So what's the difference?
It's like the difference between scribbling some notes down on a napkin versus writing a well-structured essay.
Okay, I get it. Both might get the information across, but the essay is much more organized, easier to follow, and just more pleasant to read.
Exactly. And that's what we want with our code. We want it to be easy to understand, debug, and modify later on.
Makes sense. They also mention best practices and implementing things step by step.
Right, breaking it down into smaller chunks, making sure each part works before moving on to the next.
And let's not forget about comments.
Oh, yes. Comments are crucial.
They can be a lifesaver.
Seriously, they should be concise and informative, and they should explain the why behind your code, not just the what.
Right, like you're leaving breadcrumbs for yourself and anyone else who might need to understand your thought process later.
Exactly. Think of it like you're giving a tour of your code. You want to point out the interesting parts and explain why you made certain decisions.
So it's like building a house. You wouldn't just slap some bricks together and call it a day.
No way you need blueprints. A solid foundation and a logical structure, and just like a house needs regular maintenance, your code will likely need updates and modifications down the line. So having clean, well-documented code makes those tasks so much easier.
Awesome. Okay, so we've got our code written. It's clean, it's commented, it's ready to go. But wait, there's more. Step 5.
Yeah.
Testing. Testing 1, 2, 3. And I know it can be tempting to skip this step, especially when you're feeling confident in your code.
Yeah, I've been there, but trust me, testing is absolutely crucial.
So it's not about proving that your code is perfect. It's about finding those hidden bugs, those edge cases that might trip things up down the line.
Think of it like quality assurance for your code.
Right, we want to make sure it can handle anything we throw at it.
Exactly. So Algo Academy suggests starting with those sample inputs that the problem provides, then moving on to those tricky edge cases, and even designing test cases specifically to try to break your code.
Yeah, that's a good point. Sometimes you got to try to break things to see where the weaknesses are.
Exactly. And when you find those weaknesses, you can fix them and make your code even stronger.
All right, so our code has been tested, and hopefully it's bug-free. But now what?
Now is it time to celebrate?
Well, hold on. There's still more. We haven't reached the summit yet. There's one more step.
You're right. Step 6, optimization. This is where we refine our code, make it even better.
So even if our calculator app is working perfectly, there might be ways to make it run faster or use less memory or just be more readable.
Absolutely. It's like fine-tuning a race car. We want to squeeze every bit of performance out of it.
I like that analogy. So can you give us some examples of what optimization might look like in our calculator app?
Sure. So, for example, we might realize that certain calculations are being repeated multiple times, so we could store the results of those calculations in a cache so we don't have to recompute them every time.
Well, that's clever. So we're saving time and resources.
Exactly. Or we might find a more efficient algorithm for a particular operation.
So it's all about thinking critically about our code and looking for those hidden opportunities for improvement.
Couldn't have said it better myself. And finally, we reach the last step, step 7, documentation. I know it doesn't sound as exciting as writing code.
It's often seen as the chore, but trust me, it's just as important as all the other steps.
I would even say it's crucial for long-term success.
Right, so it's not just about writing comments within the code. It's about creating a separate document that explains how everything works.
Like, imagine you're coming back to your code months or even years later.
Yeah.
Will you still understand what it does, why you made certain choices, and how it all fits together?
That's a scary thought.
Right, and that's where good documentation comes in. It's like a user manual for your code.
So anyone who needs to work with your code can understand it, even if you're not around to explain it.
Exactly. It makes your code more accessible and reusable, and it saves everyone a lot of time and frustration in the long run.
Okay, so we've covered a lot of ground from understanding the problem to documenting the solution, but we're not done yet. There's one more crucial piece of the puzzle, and the right mindset. And we're going to dive deep into that in part 2 of this deep dive, so stay tuned.
Welcome back. Right, so remember that calculator app we've been talking about?
Oh, yeah, our trusty little project.
Exactly. So let's actually put those 7 steps into action and see how they apply to like a real world problem.
Okay, sounds good. Because it's one thing to talk about the theory, but seeing it in practice is where the real learning happens, right?
Totally agree. All right, so we already tackled step 1, understanding the problem.
Yeah.
We define the inputs, the outputs of those pesky edge cases.
Yep.
All set there.
Perfect. So now let's move on to step 2, analyze the problem. So what are some key things we should be looking for during this phase?
Okay, so it's like we're detectives, right?
Exactly. We need to break down the problem into its core components. Like what are the essential pieces?
Okay, I'm following. So for our calculator app, that means figuring out, all the different operations we need to handle, like addition, subtraction, multiplication, division.
Oh, yeah. And maybe even things like percentages or exponents.
Exactly. Good catch. And we also need to consider how we're going to handle user input and then how we're going to display the results.
Okay, so it's about taking that problem and dissecting it, figuring out all the moving parts and how they interact with each other.
Exactly. And don't forget about those edge cases we mentioned earlier.
Oh, right. Like dividing by 0?
Exactly what happens if a user tries to do that. We need to anticipate those scenarios and make sure our code can handle them gracefully.
Yeah, we don't want our app crashing every time someone makes a little mistake.
For sure. All right, so we've analyzed the problem. We have a good understanding of what we're up against now. Comes the exciting part, step 3, planning our attack.
Time to come up with a strategy.
Exactly. This is where we choose the right tools for the job. We're talking about algorithms and data structure.
The building blocks of our solution.
Precisely so, for our calculator app, we could use like a simple array to store the numbers that the user enters.
Okay, makes sense.
And then for the actual calculations, we could leverage existing libraries or functions, for those basic arithmetic operations.
Oh, that's smart, so we don't have to reinvent the wheel.
Exactly. Why write code when someone else has already done it for you? But here's the question. How do we choose the right algorithm, especially when there are multiple options?
Yeah, good question. It's like standing in the tool aisle at the hardware store and being overwhelmed by all the choices.
I feel that, and that's where our understanding of time and space complexity comes into play. Remember our cooking analogy?
Dude, yeah, the omelet versus the 5-course meal.
Exactly. We want to choose the recipe that's both efficient and doesn't use up all our resources.
So in our calculator app, what would be an example of choosing a more efficient algorithm?
So let's say we need to search for a specific number in our array. We could do a linear search, which means checking each element one by one.
Yep.
But a binary search, which works by repeatedly dividing the search interval in half, would be much faster, especially for larger arrays.
Oh, that makes sense. So it's like taking shortcuts to find what we're looking for.
Exactly. And that's the beauty of algorithms. There are often multiple ways to solve a problem, but some are way more efficient than others.
So it's not just about finding a solution, it's about finding the most efficient solution.
You got it. And this planning stage is also a good time to start thinking about potential optimizations. Can we make our code even better?
Oh yeah, like how could we optimize our calculator app?
Well, for instance, could we use a hash map to store frequently used calculations so you don't have to recompute them every time?
Oh, that's a smart idea, like storing the answer to 2 plus 2 so we don't have to calculate it again.
Exactly. A little optimizations like that can make a big difference, especially as your programs get more complex.
Okay, awesome. So we've got our plan in place, we've chosen our algorithms, we've thought about optimizations. Now, let's roll up our sleeves and start coding step 4, implementation.
Time to bring our vision to life.
But remember, it's not just about writing code that works. It's about writing code that's clean, readable, and maintainable.
Right. No spaghetti code allowed.
Exactly. We want our code to be well-structured, properly indented, with meaningful variable names, all that good stuff.
Makes it so much easier for everyone involved, and don't forget those comments.
Ah, yes, our trusty breadcrumbs.
They guide anyone who reads our code through our thought process. They explain the why behind our decisions.
So crucial for debugging, collaborating, and future maintenance.
For sure. It's like leaving a trail of notes for yourself and others so you don't get lost in the code jungle.
Okay, so our code is written, it's clean, it's commented, it's hopefully working as intended. Time for step 5 testing.
This is where we put our code through its paces. You got to make sure it can handle all sorts of inputs, including those edge cases that might trip it up.
Like that pesky dividing by zero problem.
Exactly. So for our calculator, we'd want to test it with different combinations of numbers. Operators even try to break it with invalid input.
Right. The goal is to uncover any hidden bugs or issues before they cause problems out in the wild.
Exactly. And testing isn't just about doing it manually either. There are tools and techniques for automated testing that can help us cover a wider range of
Oh,
scenarios.
cool. So it's like having a robot QA team.
Kinda, yeah.
Yeah.
It helps ensure that our code is robust and reliable.
Okay. Awesome. Our code's tested, hopefully bug-free. Can we celebrate now?
Not so fast. There's always room for improvement, remember. Step 6, optimization.
Oh, right. We want to make our code as efficient and elegant as possible.
Exactly. It's like fine-tuning a car engine. We want to squeeze every bit of performance out of it.
So for our calculator app, what kind of optimizations could we make?
Well, we might realize that certain calculations are being repeated multiple times, so we could store the results of those calculations in a cache.
Oh, yeah. That way we don't have to recompute them every time.
Exactly. We're saving time and resources, or we might find a more efficient algorithm for a particular operation, like maybe there's a faster way to do multiplication or something.
Okay, so optimization is all about thinking critically about our code and looking for those hidden opportunities to make it even better.
You've got to, it's like a never-ending quest for improvement. And finally, we reach the last steps. Step 7, documentation.
I know some people dread this part, but we know it's super important.
It's crucial for making our code understandable and maintainable in the long run. Imagine coming back to your code months or even years later. Will you still understand what it does?
Ooh, that's a good point. I probably won't.
Right, and that's where good documentation comes in. It's like a user manual for your code.
Okay, so it should explain, like, how the app works, what all the different parts do.
Exactly. It should be clear, concise, and easy to follow, like a good set of instructions.
So anyone who needs to work with our calculator app, whether it's us in the future or someone else, can understand how it works.
Precisely. It makes our code more accessible and reusable, and it saves everyone a lot of headaches down the road.
All right, so we've successfully applied that 7-step framework to our calculator app, from understanding the problem to documenting the solution. But you mentioned something about mindset at the end of part 1. Why is mindset so important when it comes to coding?
It's like the difference between someone who sees a puzzle as a frustrating challenge and someone who sees it as like a fun mental exercise. The right mindset can make all the difference in how we approach and solve those tricky coding problems, and that's what we're going to dive into in part 3.
Welcome back to the deep dive. We've been walking through this awesome 7-step framework from Algo Academy, for tackling any coding problem, and we've been using our little calculator app as an example.
It's a good example, right? Kind of simple, but it lets us illustrate all the key points.
Right, exactly. So we've analyzed the problem, we've planned our attack, we've implemented the code, we've tested it, we've optimized it, we've even documented it.
We've covered all the bases.
But you mentioned something really important at the end of part 2 about mindset. Why is that so crucial when it comes to coding?
It's like that feeling when you see a mountain and you think, I can't climb that, versus thinking, I wonder what the view is like from the top.
I like that.
Right? It's all about perspective. One is limited by fear. The other is driven by curiosity.
So how do we cultivate that mountain climber mentality when we're facing a tricky coding problem?
Well, it starts by embracing those challenges as opportunities for growth. So instead of getting discouraged when you hit a roadblock, you see it as a chance to learn something new, to expand your skills.
Right. And Algo Academy actually talks about this in their blog post. They emphasize the importance of practice. How it helps you recognize patterns and become more efficient at problem solving.
Totally agree. And practice isn't just about quantity, it's about quality. Pushing yourself to solve problems that are just outside your comfort zone, experimenting with different approaches.
So don't be afraid to break things intentionally, see how they work under different conditions.
Exactly. It's all about exploration and discovery.
So the key takeaway here is don't shy away from those coding challenges that seem a little intimidating at first, because that's where the real learning magic happens.
I couldn't agree more. Those are the moments that really make you a better coder.
And don't be afraid to make mistakes either.
Oh, yeah. Mistakes are like gold. They're valuable feedback.
They tell you what's not working, and they point you in a new direction.
It's like that famous Thomas Edison quote, right? I have not failed. I've just found 10,000 ways that won't work.
Exactly. Every error is a learning opportunity. And remember, you don't have to go it alone.
Oh, that's so true. There's a whole community of coders out there facing the same challenges.
Right? There are online forums, coding communities, open source projects. It's amazing. And even just reaching out to a friend who, sometimes just talking through a problem with someone can spark a new idea or give you a fresh perspective.
Absolutely, collaboration is key. And Algo Academy also mentions their own platform as a great resource for practicing and honing your skills. They have those interactive tutorials and even AI-powered assistance.
And there are tons of other amazing resources out there too, like online courses, coding boot camps, coding challenges. It's incredible.
It's all about finding what works best for you and your learning style. But the key takeaway is that coding can be challenging, but it doesn't have to be a solo uphill battle.
Right? By approaching it systematically,
Fitting, right?
embracing those challenges with a curious mind and tapping into all those resources, you can turn coding from a source of frustration into a rewarding and, dare I say, fun pursuit.
Absolutely. You might even discover a passion for it and create something truly amazing.
That's a wrap on this deep dive into conquering any coding problem.
We hope you enjoyed it.
We hope you learned some valuable strategies and feel inspired to tackle your next coding challenge with confidence.
Remember, coding is a journey, not a race.
Enjoy the process, embrace the challenges, never stop learning, and don't forget to share your thoughts and any aha moments you had during this deep dive on our social media channels. We love hearing from you. Until next time, happy coding.